Quantitative methods for choosing projects: equity analysis, DCF and NPV. DCF analysis, discounted cash flow analysis, is a valuation method used to estimate the intrinsic value of an investment based on its future cash flows. Here are the general steps to perform a DCF analysis. Step 1. Forecast the future cash flows. The first step in a DCF analysis is to forecast the future cash flows that the investment is expected to generate. This may include estimating revenues, expenses, capital expenditures, and working capital requirements. Step 2. Determine the discount rate. The next step is to determine the appropriate discount rate to use in the analysis. The discount rate reflects the risk associated with the investment and is used to discount the future cash flows back to their present value. Step 3. Calculate the present value of the future cash flows. Once the future cash flows and discount rate have been determined, the next step is to calculate the present value of the future cash flows. This involves discounting the expected cash flows back to their present value using the discount rate. Step 4. Calculate the terminal value. After calculating the present value of the future cash flows, the next step is to calculate the terminal value of the investment. The terminal value reflects the estimated value of the investment at the end of the projection period and is often based on assumptions about the growth rate of the investment. Step 5. Calculate the net present value, NPV. The final step is to calculate the net present value, NPV, of the investment. This involves adding the present value of the future cash flows and the terminal value and subtracting the initial investment or cost of the investment. Pros of DCF and NPV. 1. Provides a structured approach. DCF analysis and NPV provide a structured approach to evaluating the potential value of a technological innovation project by considering future cash flows and discounting them to their present value. 2. Considers the time value of money. DCF analysis and NPV take into account the time value of money by discounting future cash flows to their present value, which provides a more accurate representation of the potential value of the project. 3. Provides a measure of profitability. DCF analysis and NPV provide a measure of profitability by comparing the present value of the expected cash flows to the initial investment required for the project. 4. Helps to identify risks and uncertainties. DCF analysis and NPV help to identify potential risks and uncertainties associated with the project, such as changes in market conditions or regulatory approval. Cons of DCF and NPV. 1. Requires accurate projections. DCF analysis and NPV require accurate projections of future cash flows, which can be difficult to estimate for technological innovation projects. 2. May be affected by subjective assumptions. DCF analysis and NPV may be affected by subjective assumptions about the discount rate, growth rate, and other factors that can impact the potential value of the project. 3. Ignores non-financial factors. DCF analysis and NPV may ignore non-financial factors that can impact the potential value of the project, such as the potential impact on society or the environment. 4. May be affected by external factors. DCF analysis and NPV may be affected by external factors that are beyond the control of the company, such as changes in market conditions or regulatory requirements. Overall, DCF analysis and NPV are valuable methods for evaluating technological innovation projects, but they have limitations and may need to be complemented with other methods that consider non-financial factors and qualitative aspects of the project. It is also important to consider the accuracy of projections, subjective assumptions, and external factors that can impact the potential value of the project before using these methods for decision-making purposes.